In this video, we introduce MPLAB Code Configurator, a tool for easily configuring microcontroller peripherals and libraries. We use this to first understand a peripheral's configuration and then to add functionality to a project. As we continue to build on the PIC and AVR GitHub example project that we found in the last video. So as we open our main.c from source files, MCC generated files tells us that this is an MCC project. To install MCC, we go to Tools, Plugins, search under available plugins for MCC, and install. Once the IDE restarts, we now have an MCC icon. Let's click on this icon to open MCC. We have several main areas: project resources, what is in the project; device resources, what can be added to the project. In a flat view of the tree, we can also show available resources. This is a searchable version of what we see under device resources. Under the Versions tab, we can select specific versions of libraries. There's a pin manager on the bottom here, and a package view of this on the top right. Also at the bottom, we get notifications about which components may need further configuration. Then the central area here is for the configuration of various software components. Here we see that the ADC for computation is right aligned, is auto-triggered via timer 2, and that the ADC interrupt is enabled. Looking at timer 2, we can see that it has a period of 100 milliseconds. Changing this to 1 second, as we do this, we get a hint here that the timer period exceeds the maximum possible, but if we increase the size of that prescaler, that notification goes away. To demonstrate how we can modify an MCC project, let's add a UART for Printf debugging. Consulting the kit schematics, we can see that we have a USB CDC on UART 2. So going to available resources, we can search for UART 2 and add this to our project. A baud rate of 96 is fine. No interrupts for now. Redirect standard I/O to UART means that we can use Printf statements. Next, we'll need to configure the pins. So pin manager, UART 2. And referencing our schematic, we can see that TX is on RD0 and that RX is on RD1. We can now generate code, see all the files that are generated under Output, back at Projects. Let's have a look at the source code. Every MCC project has a system initialize. Here you'll find functions which initialize the peripherals as you configured them in the GUI. Considering our example project, in the ADC callback we toggle a LED and get an ADC value. Then in the while loop, if the ADC is above a certain threshold, we turn the LED on by setting it low. So in our callback, let's add a Printf to display the ADC result. And let's program and run this project now. Okay, so programming complete. You can open the data visualizer. Here you can see there's also a kit detection we can send to the terminal. And we can see our Printf results. We're going to go further and understand a little bit more about the data visualizer in the next video. For now, going to the MCC product page, scrolling down, we can see a list of videos here which cover various use cases of using MCC. We'll catch you in the next one.